Good morning, everyone. I'd like to welcome you to Tantec's webinar. My name is Jeff Gratis. I'm the Vice President for Tantec EST. We are based just outside of Chicago, and I will be walking you through this presentation. We would like to ask for any of the questions that come up during the presentation. If you hold those off for the end so that we can reply back to those, there should be a chat box available for you as well to go ahead and type those in, and we will go over those questions once we get to the Q&A portion at the end of the presentation. So a little bit about Tantec to give you some background on who we are and what we've been doing. Tantec is a company that was founded in 1974, so we have more than 40 years of experience in providing three-dimensional surface treatment equipment. Our core focus is looking at unique solutions that will utilize corona and plasma surface treatment. Three-dimensional is our main focus, and we do some two-dimensional thick foam. Today's webinar will be focused more on the vacuum plasma side of our business. One of our main goals as a company is to be the worldwide supplier and advisor for the medical, automotive, and other quality-driven industries to share our knowledge and our capabilities for surface treating unique and challenging geometries that are typically looked at as something that can't be surface treated. Tantec's applications engineers and employees have more than 25 years of experience, so if it's something that's unique or challenging, chances are we've come across it before or we'll find a proper solution for you. We are located and headquartered in Denmark. The location is in Lunderskov, about 2 hours west of Copenhagen. And then our office in Chicago is a sales and service office for North America. The Tantec USA office is a sister company to Tantec AS, headquartered here in Denmark. Throughout the world, we are represented by agents in various different countries. As I mentioned, the Chicago office handles all of North America, Canada, Mexico, some of Central America as well. And then we have agents throughout Europe, Asia, South America to support any projects you might be working on that end up being manufactured overseas. It's good to know that there will be a Tantec representative available to support you should you need anything. Some of the industries that we focus on, medical has been a large focus for us over the years, automotive as well. Those two industries have used corona and surface treatment for many, many years. Some of the other areas we get into are cables and pipes, foam and board, packaging, electronic, metal cleaning. Those are some of the other industries where quality-driven applications allow us to utilize our plasma or corona treatment solutions. And at this point, we're going to take you to a video that will explain a little bit more about the company.
At Tantec, we consider ourselves as a close-knit team with big achievements. As the top manufacturer of ready or custom-made plasma and corona systems, we offer reliability, efficiency, and even more, innovation. We know that your industry demands forward progression, as does our solutions, with improved results for coating, bonding, wetting, printing, painting, and cleaning. Headquartered in Denmark with our own U.S. office and represented in 30 countries, we're always close by, ready to deliver solutions to both end users and OEMs. Tantec, a better way to solving your adhesion problems.
There are three main areas that surface treatment is considered to enhance or improve the properties of plastic and metal. We are looking to either improve the adhesion, the wettability, or the cleanliness of the parts. Tantec offers surface treatment solutions using plasma or corona that cover all three of these areas. Today we're going to be talking mostly about vacuum plasma, and a lot of that is going to be involving the activation of plastics and cleaning of plastics and metals in these chambers. We are using high voltage discharge in order to create those functional groups, which we'll go a little bit deeper into. But our core goal here is to improve adhesion, wettability, or cleanliness of the parts during our process with our equipment. So we'll talk a little bit here about what happens with surface treatment and how it comes about. So one of the things we like to do is measure a part's surface energy before treatment takes place. So we can do that with a variety of different methods. As you can see on the slide here, we show the pore wettability on a plastic part before treatment. You can see here where the liquid is balling up and not spreading out and creating a uniform treatment surface or a uniform surface that allows for a glue, ink, or coating to wet out and stick and adhere to the surface. The next slide shows a corona treatment process here, where you're going to see the discharge take place in the area where we want to improve the surface energy of the part. Shown here is corona. This can be done with plasma as well, but for the example, we're just showing a corona here. Treatment time in this case is very, very short. And after the treatment takes place, you can see the liquid is now wetting out on the surface. This is what we call improving the wettability and adhesion properties of the plastic material. One thing I like to stress to everybody is no matter what happens when we treat the surface and we improve the wettability and potentially improve the adhesion process, it's always important to do your own validation and testing to confirm that you are seeing the adhesion and wettability and it is providing the function that you're looking for. On this slide here, we kind of show the results of what can be poor quality in print on various devices. So we have on the left side here, you see a bottle that's been printed on with inkjet. You can see the image is fuzzy, it's not very sharp or crisp, and that's something we typically see a lot of instances where we're trying to print on a plastic material, where we see that print is just not providing the quality or the look or the resolution, especially with the introduction of QR codes. We want the customer to be able to scan that part and get the QR information on their phone. And if the resolution isn't quite where we need it to be, that QR code might not read and not providing your customer that value they're looking for and being able to check that. And then on the right-hand side, you see a key fob. This is a very, very common situation where we're dealing with high-touch areas. You know, customers touching the surface of a product they bought, and you want that logo or that information to remain on the surface. So, you know, higher-end automobiles, buttons inside of the car, even medical devices, syringes, those types of things. We want to make sure whoever's using the product knows exactly what each button or what the product markings indicate so that they're not confused or they have any risk of doing something wrong because the ink didn't stick. So realistically here is the surface energy is trying to make it more adhesive friendly and also allow for a sharper, better image in your print quality. And at this point, we've got some questions that were submitted prior to the webinar, so I'll jump here and answer one of the questions that had come in. So one of the questions that was submitted ahead of time to us for this webinar is, one of the participants asked, what are the ways that we measure surface energy? And there are really two methods that we use in order to determine that a change in the surface has been done. One of the quicker, down and dirty ways in order to check the surface energy is measuring with dye solutions. That's using an ink that we wipe on the surface and we're looking for the ink to either ball up or wet out onto the surface. It's a really quick, easy way to verify that a surface change has been made, and it's something that can be implemented very easily on the production line as well. There are some drawbacks to testing with dye solution. You are relying on an operator's ability to interpret the results. So what we're looking for is when we wipe out the solution on the surface, if it lays flat for 2 seconds or more, we're at that surface energy or higher. If it balls back up on itself, we're below the surface energy ink that we used. You can reach out to us after the webinar and we can share you some details on the dyeing kits that we offer and ways to go ahead and test materials. Another way that's used quite often and really used mostly in medical and automotive is using a contact angle. This is a tool or a device that is used that places a pre-calibrated droplet of deionized water onto the surface. And what we're looking for is the angle of the droplet on the surface itself. So the higher the angle is, the worse or the more likely you're going to see adhesion and wettability problems. The lower we get that angle, the likelihood of you seeing adhesion improvement, wettability improvement is much more likely to occur. So that's kind of the difference between the two technologies. Dyeing solution, you're looking for a high number. Contact angle, you're looking for a low number. We do have some contacts in the contact angle industry that we can provide you after the webinar as well, should you be interested in a device for doing that as well. So as we've discussed, the three areas that we're looking to get some gains from the surface treatment itself are improved adhesion, improved wettability, and surface cleaning. So we've got a couple images here on the slide. As you can see on the left-hand side of the image, the improved adhesion, you can see a syringe barrel. This is what I kind of touched on previously, is high-touch areas or areas that are really important for someone to know exactly how much of a dose or a liquid that might be in the surface. So what we're looking here is to get the ink to stick so that when somebody's touching it or rubbing that surface, it doesn't peel off and take away valuable information from the user of the product itself. Improved wettability, that's just making sure your coating or something you're trying to grow on the surface has a uniform surface that's wetting out and allowing everything to get on to the surface you're looking for. And then surface cleaning, this tends to be more around the metal side of the business, where we're trying to remove any organic films, dirt, or processing oils that may have been deposited on the metal during the processing of that raw material into a product that you're looking to work with. There is a little bit of cleaning that can be done on plastics as well. Fingerprints, handling, those types of things. It's really important to have a clean starting surface in order to ensure that you get the best result of any type of treatment and also the best result for any type of adhesion or wettability you're looking to improve upon. This slide here talks a little bit more about the angle that I touched on briefly, the wettability. So we call it a hydrophobic and a hydrophilic surface. Most polymers are going to start in a hydrophobic state. Polypropylenes, polyethylenes, polystyrenes, specifically Teflon, silicones, really challenging type materials. We then go over to the treatment process, and as you can see on the slide here, you see how the angle or the droplet is starting to wet out and spread out. That begins to make the surface more hydrophilic. This then allows for the ability to enhance that surface, to put your value-added process in place, and really allow for the product to shine as the way you intended for the operators. So as a follow-up to the slide that we just presented showing the hydrophobic and hydrophilic, I like to try and explain this in a way of real-world terms. So essentially what we're doing is we're etching or oxidizing the surface. So kind of the best analogy to kind of explain this and really go over what we're doing to the surface. If any of you out there are hockey fans or have been to a hockey game, one thing you will always notice before the game and after the Zamboni comes out and cleans the ice, the first thing the goalie does is he comes out and he etches the surface in front of the net with his skates. That's essentially what we're doing here. We're taking a slippery surface that doesn't want anything to stick to it. We're etching that surface to allow for grip and bite so things don't come off of that surface. The key difference here is you can't physically see or tell we've done anything to the surface unless you use a high power microscope or some sort of contact angle or dyeing solution to see something's been done to the surface. So from an integrity point, a visual aspect, the surface treatment doesn't change your product other than add that value to improve the adhesion and wettability. Here we're going to talk a little bit about some of the adhesion properties and some specific applications that we've come across that have benefited from a vacuum plasma treatment. One of the areas we do a lot of work in is the medical sector, and tissue culture products are a large portion of that. It's very important that they have a nice uniform surface that provides good wettability for their media to spread out and adhere to the surface so they can grow important things like vaccines, do DNA testing, cultures, all the important things done for infectious disease and development of new medical vaccines and developments in the industry. So this sector, tissue culture products, has really turned towards doing vacuum plasma and really does have a good knowledge and experience in working with plasma and surface treatment. We've been working with this industry for a very, very long time and have a great deal of experience and knowledge that we can help pass along for new applications, trying to develop a proper process that gives you the value you're looking for. Another area that we've seen a big deal of growth in is large automotive parts. So automotive interior trim parts, putting higher end finishes on these materials, wrapping them with leather, providing the foam soft touch inside there. These parts typically were a challenge before because of the size and the geometry that we were working with. But with vacuum plasma, we can build these chambers large enough to allow you to lay the entire part in there and get the entire surface treated in one cycle, as opposed to having to flip things around and run them through another cycle at that point. So the improvements that the VacuTEC allow for are taking these larger, complicated parts and being able to bring them to the surface treatment world with less cost and more efficiency, allowing for parts to be processed much quicker. So we have several standard series. You can see on the screen here several of the different models we work with. Keep in mind that these are just 4 of our standard models. We can manufacture and design plasma units to fit your application. So one of the key things that we like to know about is how many parts do you need to cycle per minute? How many parts do you need to process per hour possibly? And then we can break that down and figure out exactly the size chamber we need, how many trays we need, what type of processing do you do? Are they racked? Are they individual? Are they batch? Are they automatically loaded? All of those things are things that we can adapt to these standard and customized units. So it provides you a great deal of flexibility, provides a great deal of options for you, so that keep in mind that one thing Tantec tries not to do is ask you to change your process. We like to build a machine that fits your process. So one of the more popular units we have is our VacuTEC 2020. I'm going to talk a little bit more about this particular device. It's a smaller chamber. It's got an 8-inch by 8-inch tray. But what's really unique about this one is we use 2 sets of electrodes, one on the top, one on the bottom. So one thing that sets Tantec apart from others in the industry when it comes to vacuum plasma is we do an electrode to electrode discharge inside the chamber. So once we start the process, we remove all the air from the chamber down to about 1 millibar. At that point, we ignite a high voltage discharge that creates a plasma plume between the 2 sets of electrodes, providing a very, very focused amount of energy. What's great about this is because we're using this dielectric or this electrode to electrode discharge, in many cases we don't need to add process gases. We don't need to ignite all throughout to create that focused field in the area where we are trying to discharge over that 8-inch by 8-inch tray. Cycle times on this particular machine are extremely fast. We have a large pump on this chamber. In most cases, we can evacuate the chamber in 20 to 21 seconds, a 30-second treatment time, a 10-second repressurization, and your parts are complete at that point. It's very, very simple to operate. We like to say in our office in Chicago is if you can make a bag of popcorn in the microwave, you can use our vacuum plasma system. You have the ability to go ahead and adjust time. Time is really a function of how long the plasma treatment is going to take place. Pressure, the lower you go in pressure, the more uniform the discharge becomes. Power, the more power you use, the likelihood you could reduce the time. So you've got several factors you can adjust with a vacuum plasma surface treatment system that allows you to reach the results you're looking for. I can't stress enough the importance, though, as you do your development and your testing process, change different parameters and see where your window works and what provides you the greatest value, but always test for your adhesion, your wettability properties, and making sure that it meets those requirements. The system has built with all the safety features as well, safety interlocks, doors that are safety interlocked as well, measuring the pressure and the vacuum, ensuring that we do reach those levels. Should something not reach that, you will be notified on screen that there was a failure to achieve the necessary result or the cycle was not complete. So all of those things are available for you, so you can feel confident that when you run something through a vacuum plasma unit, you achieve the results you're looking for. As I mentioned before, we typically just use clean, dry air for our process gas, but we can add oxygen and argon if you're looking to do specific chemical changes. We just look for you to provide us with an idea as to what you're looking to add to the surface. Tantec also does provide samples treated in the vacuum plasma units that we can send back to you and allow you to go ahead and test to see if the process provided the value you're looking for. So I'd like to touch on a specific application that uses our VacuTEC 2020. So we have a small trim part here that needs treatment on the top as well as on the back side where the wrapping and the adhesion is going to take place. So what happens is these parts are loaded in, and The top side is facing the top electrode, the bottom side is facing the bottom electrode. And that's really where our technology comes into play. By having these two electrodes here, we're creating the field from the bottom and from the top. So there's no need to rotate the part or adjust the part during the treatment process. It's going to get 360-degree treatment on the part in a very, very short period of time. This is used in the automotive industry. Typically, you're going to fit about 6 to 7 of these parts per cycle. And it was easily making their rate to where the system is only being used about 4 to 5 hours a day, as opposed to some older systems that RF-based systems that might have a 10 or 12-minute cycle time. They're doing this process in about a minute to a minute and a half. So that's really where the big advantage of this electrode to electrode and not having to pump down quite so far really provides that great value in being able to do higher volume production with a batch process that normally isn't attained with a typical RF-based plasma system. We're going to show a video now of one of our customers that's currently using the VacuTEC 2020, explaining a little bit about their process and the value it's provided to them to make their product achieve the results they're looking for in terms of adhesion and wettability.
Our challenge was that our oculars didn't stick well enough to the carrier lenses, and therefore we had to find a solution where we could make the glue stick better.
We have developed systems for dentists and surgeons, and we have specialized in 2 different loop systems, Galilean system. On the other hand, we have developed also a system called Kepler system, and this is for high magnifications.
The loop is our high-end loop, and for us it was a very big issue. If we couldn't solve it, we would not be able to sell the loop, and it would have been a huge cost. We were looking for different solutions, and once we found Tantec that had a plasma technology that was able to help us. We contacted Tantec, and I spoke with a very professional salesman who knew a lot about their products, and he suggested me to send some samples to him, and he was testing them in their equipment. In the end, we actually bought the machine, and it is now in use in our production. The machine is easy to use. It was delivered as a plug-and-play solution, and it does not require a big education. Tantec was handling our issues in a very professional way. They definitely know what they are doing, and there was a great help from beginning to end. And actually they still call us now and then to check up on everything.
At the end, quality is a high priority in our company here. And with this corona treatment, we deliver a product that never fails with the gluing system.
The slide here you see is for our customized VacuTEC. This is for a system that's going to be built to your needs and your specifications. Again, here we're using that same technology of the electrode to electrode discharge. So depending on the number of shells will determine the number of electrodes that we're putting in place to create that function from the bottom and from the top. Or we could even make the electrodes vertical, just depending on what works best for you. The VacuTEC is a proven concept. We've been manufacturing these for more than 35 years. We've got a lot of great experience in building these to different automation and different racking systems. As I mentioned before, the ease of use, no need for special treating gases, and the short and fast cycle times. So really with something like this, it's all about sizing that chamber and figuring out what meets your requirement for cycle times. We can provide the PLCs that you're looking for, but the technology itself is very, very standard across all of our VacuTEC systems. We're providing that power and energy focused over your parts to provide the level of treatment that you're looking for. So some of the industries that have used this, ophthalmic lenses, medical hoses, tubes and connectors, electronic parts, automotive interior parts. Realistically here, any three-dimensional part that you're looking to do treatment on that allows you to go ahead and batch process and put these in place will really provide you a great deal of value. Polypropylenes, polyethylenes really do work well in a chamber like this, ABS. So really the best thing to do is to reach out to us and ask us a little bit more about our experience with your specific material. As I mentioned before, we do free sample evaluation at our office in Chicago. If you want to send some material to us, we can run it through a vacuum chamber, let you know the results before and after, provide a test report, and really give you a good sense for what the chamber did, what some of the parameters were, again, touching on pressure, voltage, wattage, and time in the chamber are really the big things. But what's great about this is it allows you that flexibility to do multiple parts in one machine as opposed to a dedicated machine for each specific part. So I'd like to touch a little bit about the operation of the VacuTEC. It's very, very simple to work in the system. You go in and you set your process time, how long you want the plasma treatment to take place. And this is going to vary from material to material, application to application. So it may take a little bit of development work to figure out where that process window is. But the one thing we like about the Tantec system is we try to get that process window nice and big as opposed to a very, very tight process window. So you've got that flexibility to adjust things. So you go ahead and set your process time. You go ahead and set your pressure. The key here is getting that pressure down to about 1 to 1.5 millibar. That typically provides a nice uniform glow throughout the chamber itself. And then you can go ahead and adjust your wattage. Your wattage is really a function of time. The higher wattage you use, the less time you theoretically need to go ahead and treat the part. Once you do that, you've got your program set, which can be stored in the system. You then have the option to have pull-out drawers, trays that are removable, or we even have the ability to automate the process by having automatic doors and conveyors inside the chamber and outside the chamber, allowing for these parts to flow through your automation process without involving an operator. We've even built systems that are compatible with end-of-arm tooling for robots to load and unload trays into the chamber. So really the sky's the limit on what we can offer for you to, again, fit your process and not ask you to change your process to fit our equipment. We'd like to show you a short animation of our VacuTEC variety of systems we have to offer. You can also check out Tantec on our YouTube page. We have a lot of good videos on the internal operations of our VacuTEC system as well. Now that we're at the Q&A section of the webinar here, I brought in one of our sales managers, Scott Beatty, to join me. He's already received one of the questions here, and he'll take the question and provide some details and answer that for us.
Hello. So do the parts get warm during treatment? The parts do not see extreme heat and can be handled without any worry. You should always wear gloves at this point once the parts have been treated.
Another question we received was, and this is a very common question we get on most of our projects and applications, how long does the treatment last? This is what I call the $1 million question. If I could answer this with a definite answer for everybody all the time, I would know more than most people in the world would know about surface treatment. Typically, what we say on the treatment process, how long it lasts, it varies from material to material. We typically like the customer to go ahead and do some testing, but I would say materials like polystyrene, they typically have a long shelf life of 6 to 12 months before the contact angle creeps up beyond a usable level. Other materials like polypropylenes, polyethylenes, they may last for a couple of days to a few weeks. Overall, we like to say the best method is to process as quickly as possible after the treatment is taking place to ensure you get the best result overall. Scott, you want to go and take the next question?
So the next question came in, which gas would be recommended for PTFE material? We always like to start with no gas, and we'll do the test and we'll test the dyne level. Once we find out if that is good or bad, and if we can send parts back to you, which is always recommended for you to do your treatment, then we could suggest a gas. At this point, we really wouldn't know until we do get parts in for treatment.
Yeah, as Scott touched on, PTFE is a difficult material to treat, and we like to do different variations of testing with clean, dry air, maybe argon or oxygen. But we take every material as kind of a new material. There's a base to it that we understand where we should start and how we should work. But ultimately, we want to start with the easiest process to work with, like Scott mentioned, just using that clean, dry air to begin with. And if we can functionalize a surface and provide you value there without an additional gas, then that would be great. If we need to go into more exotic gases, we turn to some of our engineers to help us with that and provide us some direction on maybe an argon or an oxygen or maybe some mixture of gas in order to improve upon the functionality of PTFE. One thing we like to say in the industry, though, when it comes to PTFE or fluoropolymers, it's really, really a challenging material to work with. So we need a little bit of time to do the development work and see what can be done to make that treatment work. And at this point, we don't have any additional questions. If something comes up after this webinar that you want to look into or have us get back to you on, you can reach out to us, email us, and we're also going to be sending the presentation out to everybody to go ahead and review with our contact details, so you'll have the ability to go ahead and ask some additional questions to us directly. But we did actually get another question here. I apologize. The next question is which is better, kilohertz, megahertz, or gigahertz? In all reality, we work with a kilohertz treatment process. Megahertz and gigahertz are more RF based, where you typically require a special gas. So we would say kilohertz is probably the technology. Obviously, we work with that, but we don't necessarily require the gas. Usually with an RF-based megahertz or gigahertz, you've got to have the consumable to ignite the plume inside the chamber. With kilohertz, we don't typically need that because we have the electrode to electrode discharge taking place. And at this point, I believe all the questions are over. Again, feel free to reach out to us after the webinar. We'll be happy to answer those. Keep in mind, Tantec also does free sample evaluations. We have these chambers in our office in Chicago. You can send parts to either myself or Scott. We provide a nice test report for you, let you know what's going on with your material. Thank you again for joining us, and please be on the lookout for an email from us with a link to the webinar so you can look at it later on, and it will be up on YouTube, our website, and LinkedIn as well. Thank you very much.